So I really want to start, we say it's from hot to cold, so I have 2 slides from the hot end. Most of you guys already were here at 11 o'clock, so maybe you know it, but in principle, starting in the hot end, one of the major, let's say, inventions or updates in the last time was our DROSBox. So with a lot of good features. The same with our new Lear design. Also important to know, to see the automatization behind. The question at 11 o'clock was how much is automized edge heater and all this stuff. So this all leads us, let's say, towards the future. Why I start with the hot end? Because together with Knut EFCO, we also have this manufacturing location in Romania. And for me, it's important to say, what are your challenges and how do we react? And normally when you look at your supply chain, over the last year, we all know what were the real challenges in the supply chain. To have it stable, to be compatible in price, and really to having this partner. It does not make sense to buy anything from a company there for a few years somewhere. You have lockdowns and so on. So here we have our manufacturing in one of Europe's best cost countries. And especially when selling something to the US, it's really like, if you look at the overall cost, it's cheaper to manufacturing in Europe because you avoid these duties you have to pay if you get something out of China. So overall cost will be cheaper. Of course, we are all here, Automation have 35 years of Newnan, the central hub for you. You do not want to wait until Germany or China wakes up. You want to call your service partner. And also together with all these acting, Europe, Asia, America, we really can say, hey, we are a partner no matter what the next election will bring, no matter what the next disease will bring, or if ship gets stuck in the Suez Canal, we will surely find a solution for this. So this, let's say, all on the problem with the supply chain, this is normally how we say we are well prepared for the future. Going a little bit more into the detail of the cold end. So really, what is the challenge you have? I think everybody of you know finding good people is one of the major problems. It's hard to find them, it's hard to keep them, it's hard to train them. Of course, you can do a lot of training and all this stuff, but you train them well and they say, hey, I quit. You always will have problem. So we also have a technology answer for this. So just for example, I want to show you height adjustment in our cutting heads. You have your cutting equipment, 10, 15 longitudinal cutter. Every time you make a thickness change, one guy is going on the platform, have to turn the little screws and so on, making the right setting, has to be there in the right time and so on. We also can automate this. So especially if you have a lot of cutting heads. Next point also, normally each cutting head needs sometime a little calibration. If you ask you guys how often this is done, nobody will answer because it's not done so often. Why is it not done? It's complicated, it needs training, you have to disassemble the head and so on, so nobody does it. But after a few years, a lot of customers complain and say, hey, your line is great, but it's not that great like it was at day one. So it's a little bit missetting. We have an automatic cutting head, so it's really something like you mount on the cutting head. We have a software tool, you press start, and the cutting head adjusts itself. So it's knocking 10, 15 times on the glass, and then he knows the right setting. So that really, let's say, the force, the touchdown force is the correct one. Can do directly on the line, no downtime, easiest way. Coming to the operator itself, avoid accidents. Normally you want to avoid your employees making too much on the line. An employee which does not have anything to do is a happy employee, and you as the customer is happy because you know the line is running. Normally you have to apply some spaces at the glass. It's always critical, it's time critical, the operator needs to be there in time, and also always interacting with glass. You have a lot of lucite on the floor. Not so nice. Here we have an automatic spacer applicator. So the rack can be completely full, 2-3 stoses, something without any interaction. All this interaction with a stacker cell, for example, we also made an interface to the logistic vehicles. So you see, this is not a Grenzebach vehicle, it's somebody else, but we make the interface to this kind of vehicle. And here it's really like it is a laser-guided vehicle, so no person is driving it. It's approaching a stacker cell, it's grabbing the rack, it's auto-acknowledge, so the stacker restarts once again if you have an empty rack. This brings it into the storage, place it there, grabs the next rack. So really there's no manual interaction with this type of interface with these LGV. No people needs to be there. Also the benefit, and this is a big trend we also see at a lot of customer, some kind of rack change system. You want to avoid operators need to be there just in time. Why? We have 6-10 stacking cells. You have everywhere an operator. And why is every time one person present? Because he has to be there in the right time. If you have a rack change on 2 different stackers, you have problems. You have the big horn, and which is the loudest one, the operator will go. So this is everything we try to help you deal the problem with your employees, with the talent, I would say. Next big thing, especially when we talk about the hot end, but for you also sustainability. I do not want to talk about efficiency class of motors or something. This is standard. Nobody is really interested. But of course, with all our line philosophy, we have energy saving operation mode. It does not have to run all the time. But also, when it comes to sustainability, reducing of waste, reducing of cullet. Here, for example, we have a short cullet scrap eliminator. So directly at our main snap roll in the main line, we can eliminate cullets starting at a slug of 6 inches. So you do not have to drive it until your main cullet hopper. You directly can eliminate it. Optimization can go down to 6 inches. So here you can increase your yield by a lot. Also, sustainability. You hate it if you have a good idea and we say, yeah, this is nice, but your line is old. On our lines, we have retrofits, we have updates. So for nearly, I would say, not all, but a lot of problems you have, we have some kind of updates, retrofits. Here I chose the example of our new Grenzebach gearbox. So together with the new conveying technology, we invented, or let's say, we made this Grenzebach gearbox to avoid the Kardanshaft. So this is one of the things. It's a retrofit. If you're interested, or even if you're bored here, go to YouTube, there's a DIY video how to assemble it on a conveyor with Kardanshaft. So it's quite easy, retrofit. And also, what you should take in consideration when you talk about sustainability is the Grenzebach equipment itself. We see a lot of customers saying, I do not want to have a stacking equipment, a cutting line, dedicated only to one product or something. You do not know what happens the next 10 years, the next 15 years, so you always should be open to say, what can we do? If you have a stacker there making jumbos up to nearly 360 inches, can also make 39 inches. So you save money for a small stacker. So not only talking about sustainability for you as our customer, also think about the sustainability of your customer. What are the big trends? Solar. Everybody talks about solar. An incredible number of 240 pattern lines we sold in China. So they have furnaces, 1,600 tons per day or something, spread it until 5 lines. We sold more than 240. Why did we sold it? Cutting accuracy. They save so much money on the pre-process. grinding and so on, that this is fine. The variety comes from solar dedicated lines only, so they only run one product. It's a standard product, the lines are cheap, less than 1.5 stacker you will get in the US, so really cheap, but we also have, let's say, prepared for future production line. So we made some modification. Of course, the lines are a little bit more expensive, but once the solar market goes down, you still have the possibility to run other products on this. Also, sustainability, looking at AV cars. They have problem with weights, so the customer always demands less thick glass, so thinner glass. Also, it's special glass. You have to treat it differently. So here, for example, I took the closed loop control for our cutting head. So on the left-hand side, you see this is a regular Grenzebach cutting head. We control the current, so this is the red line, and you see that the force is jumping a little bit. Now we also say we can control the force. So we measure the force, and then the current is accordingly. So this especially in China, we cut glass 0.2 millimeter. So this is really a great invention. Also, what you need to know, the more special the glass is, the higher the quality request from the customer is. So talking about micro scratches, edge quality, and all this. So maybe we also, or you as customer, need to focus a little bit on traceability. You want to avoid recalls, complaints for the customer. This is a very nice line we built in Europe. We had 4 robots handling 140 pieces per minute. Thin glass, 0.3 millimeter. So 130 per minute, we're talking about 30 pieces per minute at each robot. But the clue about this line is the traceability. You see the colors, or not? So you see the colors, and it's really like, normally if you have problems, cutting head was not set right, you had roller marks, damaged roller, whatever. They come in stripes. If you have failure in the tin baths somewhere, they all come in stripes. And here the customer was really able to say, okay, the blue one dedicated to one robot, green one dedicated to one robot. So if the customer a few weeks later said, hey, sorry to say, but your glass is shitty, he exactly know at which robot it was stacked, which line it was, and he can say, yes, sorry, I take back all this glass, but be sure, all the other glass is fine. So here we really had traceability, and this was, let's say, the main point about this line, because he saved so much money, because he nearly has no customer complaints, and if he has, he can react in a short time. So this really for, let's say, everything talking about sustainability. Of course, all our answers to your problems, your challenges, is technology. Just an example, we're talking about mobile operation. You do not want to have stationary somewhere. Why do you not want to have it stationary? You want to have less operators. Also talking about paced traffic light or KBI. You need to have it because your operator, you do not want to have the operator with his sketchbook next to it having all the settings, but it's his sketchbook and he do not want to share with the other one. So we want to have this, and also you should know this. You should not know this by looking at an HMI, you should know it in your office or have a warning on your smartphone if something is running not in the right way. For this preserve of knowledge, which will be very, very important in the next years or decades, when people getting, or knowledge, experienced guys are getting retired, we have something, we call it the possibility of storage of setting or operation conditions. So we do not want to have this sketchbook for 2 millimeter, make this setting at this setting. Normally when entering the product, you say this is a 2 millimeter product, and the line should adjust itself. This we are currently already doing. So we have the storage and we really can say, okay, one time you make the settings, you store it. If you have the same product 2 years or 2 days later, just load the storage and everything is preset, I would say. Of course, what is important, and this is where we see a huge demand in the last time, to automate all this. So if you look at Grenzebach equipment, nearly everything is now motorized. We want to get rid of all hand wheels and so on. And this is, of course, the reason why we do it. We need to have this data. We need to control this. So you see, we started with the big machines from the hot end. Now we're talking about bits and bytes. So the future, we are already well prepared on the mechanical side. But on the electrical side, we still see a very, very big benefit. But of course, you have to upgrade or keep up to date your line to answer to all your challenges. The main question, nobody knows what will come up in the next year. The only thing where we can help is you will be prepared. No matter what will come, you will be prepared. And this is also one of my last words. On mechanical side, we try to automate as much as possible. And the reason for this is the next step. And I will hand over to Florian once again.
Thanks, Christian. So now we come to the big topic, digitalization. Some of you maybe cannot hear it anymore, a little bit like me, because it was too long spoken about, I think for the last, decade, I would say. We're talking about Industry 4.0 and digitalization. And this is also the main reason for us, what we also found, that we also did not do everything right in the past. We were focusing a lot on digitalization, but in the end there were only less results for our customers. And this is what I would say counts in the end. That's why we want to focus now on doing it, I would say, the right way. And the first stage coming into that is, once again, the setup of our company. We are talking about ourselves as and seeing us at next Grenzebach, next technology, next generation. So if you want to do in a business like the float business, which is very conservative, it's existing a very long time, and there were not so much revolutionary ideas in the last decades, I would say. We need to, I would say, think ahead. We need to have forward-looking stuff, but we need to be also aware of the tradition. We need to know where we come from, where also our business comes from. We need to be engaged, open-minded. We need also to be a journey partner. So in the end, these are all just, let's say, words, but you need that to really focus on what is needed for digitalization. And we say that we need to, in the end, identify, we call it the value case. It was often talked about use cases for digitalization, but in the end, we need to have a value case. A value case means you need to generate value out of it. And value is one thing. For us, there needs to be value that I can sell it. And for you, there needs to be value to purchase it or buy it. So in the end, we need to have value cases. That's why we need really to make more thoughts about what do we want to digitalize, where is really the potential, which technology should be used, what is the value case, and in the end, we need to create this value together. Because we are not having a float glass line, we are not producing glass, we are providing you the equipment, so we need also your ideas, what needs to be done better, what can digitalization bring us. And therefore, in order to really do this, we set up 3 value stages, we call it. So in order to come to really a value case in the end, we need first to digitize and visualize. What you have seen in the equipment using before is that the automation level in our lines is already at a high stage. So we could get rid of the most manual stuff within the last 20 years, I would say. It's not so much left. Little small screw there and a little adjustment there, but I would say the automation level is quite high. That's why we can really now start gathering the data. The next step is we need to visualize them. But visualizing them is not helping without process knowledge. In the next value stage, it's all about analyzing, communicating, and systemizing it. Systemizing means that we need to put data together to the same reference line, to a same data point. And then in the end, which makes the most interesting stuff is creating a model. A model means how can the system know what will happen maybe in 5 hours? can the system identify what is the best setup for the line at this production setting? And this is what we are now working on. So in the first value stage, in the digitalization stuff, we already automated the most of the lines. So what we are doing now is we integrate more, let's say, we call it edge servers, for really collecting data, providing interfaces, collecting data, and having data ready with the right data points, reference to the right reference points. After digitalizing it, we need to visualize it. This is a quite nice picture because I could ask you, what do you see on that picture? And I would think we get a lot of different answers because it's quite hard without knowing what is visualized there, what it's meaning that. But if you are a process expert, you could easily see that this is the length variations of a glass plate. And if it's red, we are running out of the size variations you adjusted, for example, in our float scan plate camera, which is, for example, measuring the length of the plate. If it's getting yellow, it means there are some warnings. It's getting already critical. If it's getting red, it's a bad plate. You're creating color. But basically, I want to tell you, visualizing data is without knowing everything, also nothing. Because you see something nice, but what is helping this? You're out of situations, nothing. That's why we need, in the next stage, go more in communicating it with a KPI dashboard who an operator can read. For example, it's the same data like on the picture before, but now you see it was around 113,000 glass plates we measured, and out of them, 68 were rejected. Rejected means the length was fault and we send it to Khaled. And we had 139 warning plates. And you see it was 53 different errors who led to that. And what you see underneath is where were the main issues. So for example, with 49, the leading edge was the main problem for this plate. But also this, you need somebody in behind who's knowing where the problem comes from, how we can make this KPI dashboard. And we are, for example, the right partner for that. In the next topic, we need to analyze. And analyze means there's now a lot of mathematics in behind, a lot of mathematics in behind. We have data science, and what we need to do is really making analyzations with clusters, with a lot of mathematics stuff to find out deviations, to find out stuff which is alerting, which is not normal. But if you have analyzed the data, still you are not there. Afterwards, we need also to set up interfaces to you, because it's your data, you want to have the data as well, we need to communicate that as well. Also for that reason, we need to find ways that the data which we are generating, the data others are generating, are all coming together in a standardized interface that you can also interpret not only data from the hot and the cold end, but maybe also from the furnace, from the batch house, from the warehouse, and put that together. And then, which I tried to mention already, is the systemizing topic. So you are creating data in the mixing, for example, out of the batch house. During the melting process in the furnace, during the forming process in the tin baths, in the Lear for the annealing process, in the cold end, and also in the warehouse. And all that data has to be transferred in the right way also to the processing. And for all that, we need to find ways how to systemize them. And for example, if you are having a stress value out of the annealing Lear, which you measured there, it takes normally 10 minutes approximately in average, or 100 meters until the cold end. So the stress level you have in the cold end is much different than the one, or it was measured already 10 minutes ago. And all that you need to reference. That's why you need to put in a reference point with, for example, place and time, as well as from the backside with plate ID and also place and time. And all that cannot be done, let's say, without having a partner who is putting all that together. If you have 15 suppliers, it will be quite difficult to call in with all of them and find always the same point of reference. And a big strength of From Hot to Cold is that on this picture we are not having data at the moment for melting and mixing, but for the rest we can help.
So, Florian,
Yeah.
will GSE have that data then?
If we're coming to the turnkey approach, of course, this is the way also to having one digitalization platform, one ecosystem over a complete float glass plant. So with GSE, if we're having Sorg furnace and Sorg batch house, of course also we will partner with them to have same data, one interface, and providing everything. So they will be also integrated. We could also integrate different stuff, but you know, we are in a level where we are not wanting to state that we can compete against a DCS system already, because there are systems already available. We see us more at the moment as a junction point for having standardized data over the hot and cold end, which is provided then, for example, to the DCS system. But of course, we can go also one step further. So after this systemization topic, we come to what Christian already mentioned. At the point where you have fully automated your line, there's nothing manually done, where you digitalize all data, where you have everything referenced to one set point. Of course, you can now put data together and store data. For example, this is just an example saying for 2.2 millimeters, you had different yield levels, and it's just mentioning you could have just like a lookup table for settings, and you could say, I want to have the same setting like last year in December because there the yield was pretty high. But it's still manual. You still need to know what was behind the settings, what were the production conditions, but this is already now there. And what we're working on at the moment, we have some prototype and pilot project, is in the end, we call it the intelligent settings optimizer. So the idea would be with AI, with different mathematic models in behind, that the system is seeing, according to the data, how the production is running at the moment, and it's telling you which setting would be better. How you should set up, let's say, how you should change maybe the cutting force. So if there's something with the length of the plate that they say make some maintenance there, adjust it there, or that it's even doing a length adjustment inside the system automatically. And this is where we see still a huge potential and huge benefits, because it will help the problems with the people. It will, I would say, solve also problems with that different shifts have different yield levels because of different ways they're acting, different ways of their experience and their knowledges. And this is for us one major step which fits perfect to our from hot to cold approach. So basically the digitalization leads then again to this, that we need to create value together. I'm not sure, but the QQR approach we are presenting, I think already for the last 5 or 10 years, where we still say we need to have added value in regards to the quality or to the quantity or to the resources. All these three things will lead to benefits for you. And this means if you have benefit, I guess we will also create benefit on our end. So this is, let's say, the sum up of our from hot to cold approach, or from the benefits, because sometimes we get asked what is different. I could in the past buy a Lear from Knut and a cold end from Grenzebach. Now I buy a Lear from Grenzebach and a cold end from Grenzebach, but I still buy 2 times of equipment. We are negotiating maybe 2 times different rounds, 2 times different players, so it's still 2 times equipment. And we are focusing on providing you more benefits. And the benefit should be we can provide a more stable process with our digitalization or our digital environment, and with putting together, let's say, the best out of the Lear and the cold end and put it together. We are giving you the chance for smoother glass handling, because we can coordinate really the speed of the Lear with the speed of the cold end. We can synchronize that perfectly, and we have one process control over the complete area. We can maximize your yield with AI-based optimization. So with what I've shown you, we are sure the yield will increase. But we are not there, to be honest. I said for the model, for the last stage, we are not there, but we are working on in prototype projects, pilot projects, and we are quite enthusiastic already about the results. We also see a huge benefit in easy and fast integration, because we want to send, let's say, one team for doing everything. Are we there already? No, but we are working already on that topic, that we have one commissioning team, let's say, that you have only one project leader, one guy to contact for all that stuff which you can get from us. And this should be for you also a benefit. Then we think also it should be a less effort and it should limit risks, because you do not need to fight with 2 suppliers about a shipping date or about payment terms or anything. You will have one single source. We can limit the risks in this area also, and it should be less effort for you also. Also in purchasing, in negotiations, a lot of other stuff. We also say you need minimal internal resources. Also, your engineering team should not need to contact 5 or 10 different people. It should be one single source. We should have one discussion, and we should find the best solution for you. We can provide efficient predictive maintenance, and I also mean we could provide the best service, because one service team is handling the service aspects over the complete scope of supply. So from hot to cold, it's not like you need to call 10 different people. You have one hotline. When you have a problem, you can address it, you can name it, and we solve it. And then in the end, also with our service approach, we are also providing you for the lifetime of the line, which is sometimes much longer than I want to have it maybe, but even for more than a normal lifetime of a float vessel plant. So for more than one campaign, we are providing you continuously improvements with updates, with retrofits, with things where we can help you increasing the yield, helping you reducing maintenance, or helping you the line lasting longer. So with all of that, I hope I could show you that there are a lot of benefits from our from hot to cold approach, and I hope I could also show you that we are much more than just an equipment supplier for, let's say, the cold end or the hot end.
Are you able to put a percentage value creation there? So based on the as-is and the to-be, you say all these benefits are you able to say it's going to save you 5% a year or over the lifetime?
That is quite difficult, because I'm not knowing how much you are needing at the moment, for example.
No,
but of course,
point,
we need to work on these numbers. That is clear for me as well. It's like soft targets, and we need to put it into numbers. But it's also a long way to go, because it's not so. Also, our customers are not so transparent and willing to share everything with us, because if you are telling me you're saving 10%, then you know what I want, how I will increase my price.
Yeah.
That's why it's quite difficult, okay?
It's a Grundy back way.
No, maybe not like that, but somehow we need to survive. Okay, and that would be our presentation. Are there any questions? Anything we could help you out? If not, thank you very much.
Thank you.
And have a nice day. And I hope you enjoy the party.
Yeah.